how to think about changing the ordered pairs for your graph to get it to flip or shift, depending on what's going on with the graph. Today we're going to then continue to talk about a little more depth with graphs and looking at graphs and being able to describe not only how it shifts, but also their domain and range, which we use those terms at the very beginning of the chapter. We kind of defined them and looked at why something was a function. We haven't really used it yet. So the little packet that I passed out to you is going to be the notes that we use today and tomorrow, kind of separate from the packet. But Nick, are you good with 23? Yeah. Okay.
The original equation was y equals 3 f of x plus 2 minus 1. And so I took the original t-chart, which was negative 2, 0, 0, 2, and 2, 4. Made it, and subtracted 2 from x, multiplied y by 3, and then multiplied y by 3 and subtracted 1. So we got 4, negative 1, negative 2, 5, and 0, 11.
So he has his original graph on there, which we drew at the top yesterday. That was this line, and the line was f of x equals x plus 2. So that was the original graph. And that's how he has those points. Nick, can you just describe how the graph shifts? So if you were just asked to explain the transformation of the graph, how would it shift? What would go on with it?
It shifts left to up, down 1, and it gets steeper.
Very good. So looking at his t-chart here, the x minus 2, if it's shifting left, you're subtracting 2 from x. So if you say a graph shifts left, you're taking your x's and subtracting 2. The y values, he has that little like formula up there, which is perfect. You can write yourself a formula and then apply the current y value that you have to the graph. So it's stretching with a 3, which is why you have to take 3 times y. And you do that first because you do multiplication before you add or subtract. So you're stretching the y, and then you're shifting it down 1. Nice job, Mike. Very nice. Questions on 25? Nina?
I've used different points.
Of course, yes. So you could have picked 3 different points as long as they were on the original line. So you should still have the same line. You might just have 3 different points that are removed. Other questions on that graph? So, no, you could have graphed the one line since we graphed it at the top. I think he had it on there to kind of show the difference between the two. Other questions? Alyssa has the word problem at the bottom, which was an absolute value function.
Okay, so to find the maximum number of sales, you would use the 5 and the 20 to get the point there, which is the vertex, and it was reached in A. And then the minimum number of sales would be, you would take your original problem and add the 12 in for T, and then you'd get 15, which is your lowest point that you have. And that was reached in December. And this is from your equation,
And how do you know how your equation moves? Like how does the graph shift based off the equation?
it would move to the left, to the right 5, and 120.
Yeah. So based off that equation, again, looking at the numbers in the graph and the translation. So inside, I know it says t minus, but that's the formula part. The 5 is positive, so it's shifting right 5 and up 120. That gives you that top point. And then the negative 15 says you're going down 15 and over 1. So she plotted a couple of points on here, and then she calculated that last month being the lowest month, because you can see that as the graph is going down, the 12th month is going to give you the lowest value based off of the graph for the 12 months of this year. So she plugged in a 12 and found that it to be 15 points. So that last question she did algebraically, whereas 26 she looked at the top of the graph. Nice job. Any questions on the 25, 26, 27? So I wanted to go over number 24 with you, just so that you have another problem that you're kind of looking at with this transformation. So similar to the one that Nick did yesterday, we drew our graph at the top, so we had that line of x plus 2. So right there's my line at the top. I picked the ordered pairs -2, 0, 0, 2, and 3, 5. You didn't have to pick those ordered pairs. Nick's were slightly different than mine. Just need 3 points on the line to kind of use those 3 points on the line. So looking at 24, 24 says we have negative f and then x minus 1 plus 3. So before we even graph it, who can kind of just describe what's going to happen with the graph? Jack, what's going to happen with this graph?
It's going to flip on the reflection on the x-axis.
Yeah, so flip, reflect, either one of those.
Go right 1.
Good. So the negative part makes it flip down. And even if you said reflect down, flip down, any of those words are fine. But if a graph is going up and it has a negative, it's now flipping down. And then he also said it's going to go right 1 and up 3. And that's just kind of looking at the equation starting on the left side with the negative sign and then moving to the inside the parentheses and then that last piece. So looking at that, kind of describing how the graph moves, we can make our table or our little T-chart. Right 1 means my values for x are going to increase by 1. So any x value, I would add 1. And then he said it's reflecting on the x-axis and it's moving up 3. So there's a negative sign in front. So that means there has to be a negative sign with the y, because f of x and y are interchangeable. They mean the same thing. Y is f of x. F of x is y. So we have a negative y, and then we would add 3. So you're making the y values negative, and then you're adding 3 to the graph. So I'm going to graph that original function that we had from before, just so that you can see the change. No, you didn't have to graph this on every problem because we graphed it above. So then looking at our original ordered pairs, my original x was -2. If I add 1 to it, I now have -1. My second original x was 0, adding 1, now it's 1. My third x was 3, so if I add 1, now it's 4. So I'm taking these x values at the top of my page in the T-chart that I made and just adding 1 to x, because that's what it means if it's moving to the right. With the y, I have to first make it negative, and then I need to add 3 to it. So I had a 0. Well, -0 is still 0. And then add 3. I have 2, so now it's -2, add 3. I have 5, so now it's -5, add 3. So I should still have a line. It's just that line is going to shift right and up 3, and then it also should be a reflection. So it's going to look a little different because it's reflecting. So if I just graph these 3 points, pen marks. So there would be my new line at -1, 3, 1, 1, and 4, -2. And you could see that reflection part, the part that it's kind of going at a different angle. So it was increasing, and now it's a decreasing line. questions? So if you could please make sure your name is on that worksheet and pass it forward. Does anybody need a stapler? I'll pass 2 around, one on each side. If you staple it, you can just pass it forward. So the front page was the absolute value graphs that we worked on Friday. The back of the page was like just a transformation and trying to get the graph to shift with that function notation. And we will be doing that shifting, translating, transformations. That'll be something that we do like sporadically throughout the year. Every time we graph, we will also translate a function. So that's just something that'll kind of spiral throughout the year. So again, after you get the stapler, you can pass the worksheet forward. And then if you'll take out just this tiny little packet that I gave you that has domain and range at the top. The front of the page has a couple vocab terms. See if you can write the definition of a function. So it was on the first quiz that we had for chapter 2. It was on the last quiz that we had for chapter 2. We're going to look at graphs and see how or why they're functions. You still, okay, gotcha. Stapler's coming around. Trying to read my stapler, Brady? So what is the definition of a function? Chris?
I said for every input value, which is the x value has exactly one output.
Exactly. So each input has one output. Or every input value has to have exactly one output value. But the key is that a function correlates or relates an x and a y, an input and an output, but you can only have one of them. And we are going to start looking at the input as being our x value and the output as being the y. What test can we use if we have a graph to determine if it's a function? Peter? Yeah, how does the vertical line test work?
If you draw vertical lines down your graph,
Perfect, which is the other way to explain each input has exactly one output. So a function, each input has exactly one output, and we could also say it passes the vertical line test. So that's what makes a graph a function. So there are 2 other words here that we talked about at the beginning of chapter 2. We also talked about last week when we were doing linear regression. The difference between a discrete graph and a continuous graph. So discrete versus continuous. Josh, what do you think?
Discrete is just points on the graph.
Yeah.
Continuous is a line.
So the linear regression graphs were all discrete graphs. They were just points on a graph. We created then a best fit line that went through a good number of those points, but they were scattered points on the graph that if I did connect them, it would have been a jagged line. So discrete, unconnected points, just points on the graph. Whereas continuous is a line or a curve, because not every graph is a line. Now, yes, we've happened to graph lines and absolute values, which are both linear. Absolute value is just a positive and a negative slope. But continuous, a line or a curve with no breaks or gaps. So, easiest way is if you started tracing the graph on the left and you traced it with your pencil. If you didn't lift up your pencil by the time you got to the end of the graph, then it's continuous, because it has one continuous smooth curve as you're working through it. You have to lift up your pencil at about another point, then it's not continuous. So continuous starts, moves on the whole way through a line or a curve. So the other two questions we're going to look at were the domain and range, and that's what we're going to focus on today. There are 3 different ways you can describe domain, maybe even 4 different terms that we could use. Chris, do you have one of the terms?
Independent variable.
Yeah, so independent variable. So that's one way we can describe domain. Jack, how else?
X or input.
So he said the X, the input. There's actually one other word we could use. Begins with C. Jack? Control. It's the control variable because it literally controls what Y does. It's the independent variable because that's the number that you plug different answers in for, numbers in for, and then out, your output value is your Y. So when we list the domain, we're going to actually now be describing a graph from left to right. So the domain describes the graph, and I'm going to say the movement of the graph from left to right. You always read a graph starting on the left at the negative side, moving to the right, just like we would read words on a page. You start on the left, you move to the right. We're going to use inequalities to describe that. And I'll show you how that's done. So remember, inequalities are your greater than, your less than, your greater than, equal to, less than, equal to. So we're using inequalities to describe the movement of the graph, or the path the graph takes from left to right. So domain, input, X variable, independent variable, control variable. 4 different ways we can describe domain. How about the range? Peter. Dependent variable. So if the domain is the independent, the range would be the dependent. What's one other word we could use for range?
Y variable.
Say it again?
The Y variable.
Yeah, the Y variable. And of course, it's also known as the output. So this describes the graph from the bottom to the top, because now it's a vertical description of the graph. So domain is left to right, because domain is X. X moves left to right. The range is from the bottom of the graph, still starting at the negative, and then it goes to the top. So where does it start, how low, and then how high does it move? So that's what we're really going to focus on today. Yes, we're going to look at graphs and say they're continuous or they're a function, but our goal today is going to see if we can describe the domain. How wide is the graph? How far does it stretch left and right? And we're going to describe the range. How high would it go? Or how low does it go? So that vertical stretch of the graph. So if you open up your graph, or your packet, you'll see on the next page, just flip it over, there are a bunch of examples, I think 9 of them. And the 9 examples give us a picture. because that's what we're talking about. We're looking at graphs. And like all of this week, we're focusing on graphs. So we are going to see if we can state the domain and the range, tell if the graph is a function, and then also state if it's discrete, continuous, or neither. So it might not be discrete, a set of points. It might not be continuous, because there's breaks in the graph, so then we would just say neither. So let's look at number 1, and first decide if it's a function. Let's do that. Skip over domain and range. Nina, is number 1 a function? Why not?
Because it doesn't have separate points.
Right, so right here, vertical line test. There are 2 points on my vertical line, so it's not a function. If it's not a function, then I don't have to decide if it's a discrete or a continuous function, because discrete and continuous only go with graphs that are functions. So no, this is not a function. So then we're going to try and list the domain. Now because this is just points, my domain is not connected from one point to the next. You're going to list the x values of the points. So what x values exist in this graph? Nick, what x values exist?
-3, -2, 1, 1, 4.
So he said 1, 1, which once I write it, I don't have to write it again. And then he said 4. We're going to put those little squiggly lines around it because this is a set of points that represent our domain. So if you can draw them, awesome. If not, try your best. Those are called braces. So you've got brackets, you've got parentheses, those little squiggly guys, they're called braces. So when it's just points, we list the domain as the x values that each point touches. And if there's a point that's on the same x, we don't have to write it again. So that would be our domain. So looking at the range would be the y values. Katrina, can you give me the y values that the points touch? Starting from the low point going to the highest point.
-4, -2, 3, and 5.
And there's one other one that's kind of hidden, hard to see.
No,
0, yeah. So -4, -2, that 0 is tricky to see. And then 3 and 5. So another way to tell if something is a function is if you have more range values than you have domain values, then it would not be a function. Because I have too many y's. So that's all we have to do for that graph. So the domain is just the x values, the graph where the points touch. The range are just the y values. Because the points aren't connected, I don't want to use inequalities, because inequalities say that there's a connection from one movement or one point all the way to the next. So looking at the second one, again, skip domain and range. Let's go down to the function part. Gabby, would this one be a function? Why not? Yeah, this one fails the vertical line test again. We got a pentagon, but it's not a function. So now we're going to see if we can describe the domain. And when you describe the domain, you want to look to the left. What is the furthest x value to the left? So Peter, what's the furthest x value to the left? -3. So now we're going to use inequalities. Peter, can you first give me, before we use inequalities, the furthest x value on the right that the graph touches? 3. So I know that it touches a whole bunch of other points, and it goes high and it goes low. But we're worried about the x values of the graph. So how wide does the graph stretch? Well, it stretches from -3 to +3. So then we're going to place an x in the middle because it's describing the x values. And then I need inequalities that go in here. Peter, what would the inequalities look like? Your inequalities will always face the same direction because you're starting with the smaller number, which is less than or equal to the bigger number. So small number on the left, bigger number on the right, the inequality should always be the same. It's less than or equal to because they're points on the graph. That's why we have less than or equal So then looking at the range, doing the same thing, reading the graph from the bottom to the top. So starting at the bottom, pull what's the lowest point that the graph goes to? -4, and the highest point is?
3.
This is our y variable because range is y. And then again, the inequalities always go the same way. Because I'm starting with the smaller number, that smaller number has to be less than the bigger number. So always inequalities point in the same way. You shouldn't have to worry about the inequalities, they're always going the same way. Questions? Alright, so looking at number 3, is this one a function? Yes, number 3 is a function. So then is it discrete, continuous, or neither? Josh, why do you say neither? It doesn't go further up to the, what'd you say? Okay, so he's saying it's not going further on to the left, and that's actually okay. As long as when the graph starts, it has continual movement to wherever it ends, we consider it continuous. So this is a continuous graph. So Nick, I see where you're thinking, because you're like, well, it's not continuing on the other side. But wherever it starts, from that starting point, it has to move the whole way without having any breaks in the graph. And then the graph does. So then the domain, starting at that point on the left, Josh, what is that point on the left? -4. And it continues on the right, because it has a little arrow. That little arrow means it goes on forever. Josh, what number goes on forever? What number is that? When you say it goes on forever, where does it go? What's the biggest number that could exist? Infinity. So the graph, if the graph continues on forever and it doesn't stop, we say that it goes to infinity. Josh, do you know how to draw an infinity symbol? How does that infinity symbol look? Yeah, it's like a sideways 8. So think of a snowman that you have in your yard when it's snowing. And that snowman, when you come home, has its head on the ground. So an infinity symbol is kind of like two zeros connected to each other, an 8 that kind of fell over. You'll get better at drawing the infinity symbol as you draw it more. So going back to the -4, the open circle at -4. Josh, what does that mean? Yeah, it's just less than, because -4 isn't a point. An open circle means that doesn't exist. It gets really close to it, but it's not that exact point. And then infinity, do we actually know what number infinity is? No. So we're also going to just use the less than symbol for that and not equals, because it can't equal a number if I don't know what that number is. It just goes on forever. Questions? So looking at the range, start from the bottom of the graph, where's the lowest point, and then how high does it go? So you're focusing on left point, right point, low point, high point. So Ava, what's the lowest point of this graph? 1, yeah, the lowest point is 1. And the highest value is? Infinity, yeah, because it's also going to go up forever. So it's going to continue to stretch left, but it also stretches up. And then we need our inequality symbols. So Ava, what do you think is the inequality symbol with the 1? Is there a point there? Yes. So less than or equal to, and then that one's just less than. So if there's a point, it's equal to. There's an open circle, it would just be less than that value. So looking at the next set of graphs here, see if you can do the domain, the range, and it's just a function. We got a circle. This looks like a circle. So there really isn't work for domain and range. It's a visual interpretation of the graph. How far does it stretch left and right? How far does it stretch from the bottom to the top? what's the domain for the circle?
-2 is less than or equal to x, which is less than or equal
The range?
to 0 is less than or equal to y, which is less than or equal to 4.
And then is it a function? No. Nice. Good job. So number 5, this one's a little trickier. I'm going to take a shot at it, Peter. What do you think?
Negative infinity is less than x, is less than
Good.
it's the same thing.
And he said the same thing for the range because it's a line. It goes on forever. So it's going forever left, forever right. It's going forever down and forever to the top. So we could actually, that should be a y, not an x. We could write this a couple of different ways. So we can write it exactly how Peter has told me. There's another group of words that we could use when you say negative infinity to positive infinity. And that group of words would be all real numbers. So I could also use that to describe the domain and the range because it's hitting every single number. Does anybody know how you write a symbol that represents all real numbers? So there's like a little symbol that we use to represent all real numbers. Michael?
Like an R, another line.
Yeah, nice job, Michael. So he said it's an R with an extra line. So in English, your teacher might give you that, I think the paragraph symbol is a P with an extra line, right? So all real numbers is an R with an extra line. So you could write the little r with the extra line, or you could say negative infinity is less than x, which is less than infinity. Both of those are acceptable answers. And then the last part, Peter, is this a function?
Yeah.
And if it is a function, is it continuous? Yeah. Any questions so far? Stephen, how about number 6? So thinking about the domain, how far does it stretch left and right? Yeah, so you could just say all real numbers. Or you could say negative infinity is less than x, which is less than infinity. Either one works, but it's going to stretch forever left and right. It's a V. It has the little arrows going in both directions. How about the range, Stephen? What's the lowest point that it goes? Yeah, it goes to starts at -5. That is a point on the graph. And then how high does it go? To infinity. Is this a function, Stephen?
Yes.
Yeah, passes the vertical line test. Does it have any breaks in the graph? No. So therefore it's continuous. So there are 3 other graphs at the bottom. Get a little more interesting, I think, with number 8 and 9. Emma, what do you think the domain is for number 7? So where does it start at on the left side? It starts at 0. And then where does it go to on the right? Infinity. Okay, so we could write it like that. Emma, what's the range? That one's all real numbers. So the range is all real numbers. It's stretching, it's gonna get wider and wider and wider, so it's gonna go down and up vertically, down vertically, up forever. Is that what a function is? No, not a function. So 8 looks a little different because I have a line going left and I have a horizontal line going right. Jack, what do you think for the domain? Yeah, why?
Because it goes
Heck yeah, it goes left and right. It continues forever. Even though they're separate lines, it's still touching every single point. Jack, what's the range though?
1 and 3.
Yeah, just 1 and 3. Those are the only two y values that it's touching. Just the value of 1 and 3. So we're going to put those little braces back around those two numbers because it's a set of numbers. It's a group contained together. So just the numbers 1 and 3. Is that a function, Jack?
No.
No. Right here. Those 2 points. It doesn't pass the vertical line test. All right, this last one's a little weird. Because we have a line with a little circle, a constant horizontal line, and then another line that ends in a circle. What do you think, Nick?
Domain is negative infinity is less than x, is less than 2, but x is not 3.
Okay.
Negative 3.
So he says negative infinity is less than x, which is less than 2. And then he said x cannot equal, he said 3. So I'm actually going to write that as 2 separate pieces, Nick. So one piece with, like if I stop right here at negative 3. That would be negative infinity is less than x, which is less than negative 3. So because there's a hole in the graph, I'm going to stop at that point because that point doesn't exist. And then Nick, if I give the domain then for the rest of it, it would be, bless you.
Negative 3 is less than x, which is less than 2.
Right. So because that hole in the graph, that's a break in the graph. That's where it stops. So like we're going to describe the piece up until the break, and then we're going to describe the rest of it as well. That's a little weird. Nick, how about the range? Bless you.
Is less than y, which is less than infinity.
I think my board froze. It's a little slow. So he said negative 2 is less than y, which is less than infinity. Can you say less than or equal to negative 2? Does it touch the value at negative 2 somewhere? Yes. So it touches it at this horizontal line right here, so we can say less than or equal to. Because even though there's a hole at one place, the rest of it has a little line, so we can say less than or equal to. And then it does go up to infinity. This part continues on. I got a little lag time going on here. Is it a function? Yes. Is it discrete? No, it's not a set of points. Is it continuous? No, it stops at this point. So then we would just say neither. So your worksheet is actually in that packet. It's just the next page. And I think there are a dozen problems on there for you to get the domain and range for. Is it a function? Is it not a function? I will post those answers to Google Classroom so that you can be checking them. And I'll probably also have like another group of answers posted in the same picture to kind of save an extra post. Have a great day. Hopefully your homework is pretty straightforward. There's really not work you're showing for these graphs.